All right, question 1F. Personally, I don't really like this question, but there we go. I think it's quite brute forcey and doesn't have any beauty in it really. So for a real number x, we denote by that thing x, what was floor function, right? The largest integer less than or equal to x. Let fx be x over 2 minus, well, that thing, x over 2. The smallest number of equal width strips for which the trapezium rule produces an overestimate for the integral 0 to 5 is how many? Okay, so integration of question, right? And is a weird function. So, the most sensible thing to do is to actually draw what fx looks like, right? For us to, realize what sort of thing is happening. Okay, so let's actually try to draw fx and see what happens. Okay, so we're going from 0 to 5, right? So, okay, when x is 0, then obviously it's 0, right? So, okay, good start. All right, now what happens when, when x is increasing? Let's think about that. So, now this floor function, stays at 0 for x is less than or equal to 2. No, less than 2, sorry. When x is less than 2, then, this floor function stays at 0. So we could conclude that, okay, from 0 to 2, it's going to just follow, this is just going to be the equation y equals to x over 2. All right, and, then we know that the top is 1 because the gradient is 1/2, right? So just do the maths and you'll know. Okay, but what happens when x equals to 2? Well, when x equals to 2, well, the floor function is sort of, becomes 1, right? So it becomes 1 minus 1, and haha, you're back to 0. Okay, so this function does something like this. Okay, and what happens next? It's sort of the same thing, right? Because, when does the floor function, increase again? Well, at 4, right? Because 4 over 2 is 2. Okay, so it does something like this. And then, from 4 to 5, well, it does half the line, right? Okay, so in that case, we now know how fx looks like. And, what sort of area does this thing have? Well, this, we could split into triangles, right? My diagram is not the best, but you could probably see that this triangle has area 1, and this is area 1/2, right? Well, not 1/2. What am I chatting about? This is 1/4, isn't it? Okay, so in this case, that is 2 1/4, right? 2 1/4. Okay, I hate mixed fractions, so maybe 9/4 is the better one, or maybe decimals. It doesn't matter. Okay, 9/4 maybe. Okay, now, okay, so let's see what happens. So we need an overestimate of the integral. Okay, so well, let's just try one by one, right? Because we want the smallest number, so it's probably wise to start trying from a, right? Okay, so let's try from a. So I need 2 strips in a. So what I'm saying is that, okay, let me change the color of the pen, because if not, this is going to get very messy. So this is 2.5, and I'm saying that, okay, well, we could make some sort of trapeziums. 2.5 is probably here, and, I could make trapeziums like this, and then this trapezium is here. Okay, what sort of area is this? Well, let's do the maths, right? So, triangle is 2.5 times how many? Well, chuck in 2.5 into the equation. What does that give us? So, 5/4 minus 1, which is 1/4, right? So 2.5 times 1/4, what does that give us? You see, that's why I hate decimals. It can't multiply properly. That's 5/2 times 1/4, which is 5/8, fine. And how about the trapezium here? Well, this is 1/4, right? And here, this is 1/2. So in that case, the area of the trapezium, which I'm sure we all know how to calculate, times 1/2 there, equals to what? 15/16. Okay, oh, I just realized that I didn't halve the area of the triangle. Okay, well, I'm pretty dumb, aren't I? So half that, that's 5/16. Okay, that's 5/16, not 5/8, okay? Obviously, I'm human, okay? So, what's the area then? What's the area when we have 2 strips? Then that's 5/16 plus 15/16, which is what? Which is 20/16, which is, how many is that? Well, 9/4, is it? No, not 9/4. What am I talking about? 5/4. Okay, 5/4. Right, so it's obviously smaller than 9/4, right? Obviously smaller than 9/4. Okay, so in that case, this is the underestimate. Okay, 2 strips is an underestimate. Okay, all right, cool. Now in that case, let's do 3 strips. Okay, so now 3 strips is slightly annoying, right? Because you actually get like 1/3 and stuff like that, which is not ideal, and I'm having a really hard time trying to erase all of these. Okay, maybe I should just change the color of the pen, and then it'll be fine, right? Okay, so let's go green instead. Okay, in that case, let's try to split this into 3, and then, you'll know where the areas are. So let's do something like this. Okay, and obviously this is 5 on 3, this is 10 on 3, and so on, right? Okay, so, well, area of the first triangle, let's go. So, this should be 5 on 3. Okay, let's do it here. So the area of the 3 green things, 5 on 3 times 5 on 6, okay, times 1/2. Okay, good that I remembered this time. And, okay, next one, trapezium. What's a trapezium here? So this point is 5 on 6, right? What is that point? Interesting. What is that point? That is 2/3, right? That's 2/3. Hopefully I'm right. Okay, so this is 5 on 6 plus 2/3 times 5 on 3 times 1/2. Okay, and the last one, so plus 2/3 plus 1/2 times 5 on 3 times 1/2. Okay, what does that even evaluate to? Well, something ridiculous. Okay, so well, let's just do it. So that's 25 over 36, is it? Plus how many? So 5 on 6 plus 2 on 3, that's 9 on 6. No, is it 9 on 6? Yeah, it is 9 on 6, right? Yes, okay. Too early in the morning. 9 on 6, so it's 3 on 2. Okay, 3 on 2, so blah, 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 so that's 5 on 4, right? And here, 2/3 plus 1/2, that's 5 on 6, right? Yes. No, 7 on 6. 7 on 6, and then so 7 by 5, 35, so 35 over 36. Okay, well, is that bigger than 9 on 4? Let's see. So the middle becomes 45 over 36. Okay, so 25 plus 45 plus 35, what does that give us? So that gives us 105, so that's 105 over 36. Okay, but 9 on 4 is what? 81 over 36. Okay, so 105 is bigger than 81, so hooray, we